Hi everyone, in the previous video we explored the production in the short run, where we have at least one fixed input, and now it's time to move forward and examine the long run. Unlike in the short run, in the long run all inputs are variable, which means including capital and labor, which means the firms are not constrained by any fixed resources, allowing them to adjust all factors of production to find the most cost-efficient combination for any output of level of output. So the question here is how does a firm decide on the best combination of capital and labor to produce a certain level of output within its budget? And this brings us to two fundamental concepts in the long run production. First is isoquant, and the second one is isocost. So let's start with the isoquant. So an isoquant is simply a curve that shows all combinations of capital and labor that result in the same level of output. Think of it like an indifference curve, but here for producer instead of consumer. We'll see an example. Here we have a table here. We have capital, and here we have labor, and we have the same level of output, which is 10 units of output. What does this mean? It means that if the firm choose to use 25 units of capital and 4 units of labor, the firm is allowed to produce 10 units of output. And if the firm choose, instead of this combination of 25 of capital and 4 of labor, the firm choose to use this, for example, 5 unit of capital and 20 unit of labor, but the production is the same. The level of output is always the same, and it is 10. So whatever the combination you choose here, 25 of capital and 4 of labor, or 10 of capital and 10 of labor, or 5 of capital and 20 of labor, your output will be the same, and it will be 10. This is what we call the isoquant, and it can be illustrated in this curve here, like this. This curve is the isoquant of a firm to produce 10 here, to produce 10 output. So the function is Cobb-Douglas function of production. So to produce 10 unit of output, you have this isoquant curve or indifference curve, which means you take any point here. For example, if you choose to produce at this point, it means something here between 17.5 and 15 of capital, and between 5 and 7.5 of labor. You will get the same level of output, which is 10 units of output. So anything that lies in this blue line gives the same amount of output. So it's called isoquant, which is similar to the difference curve in the consumer behavior. And now before moving to the next concept, which is isocost, there is another concept which is really important, which is the MRTS, or the marginal rate of technical substitution. So MRTS is actually the rate at which a firm can substitute labor for capital while keeping output constant. Here, for example, we said all those combinations gives the same output, Q equals 10. Q equals 10. Now let's see what does MRTS means here. We said it is the rate at which you are the firm is willing to sacrifice capital to get more labor. For example, here we have 25 of unit of capital and 4 unit of labor. Here, to move to the second combination, the firm is willing to give up 15 units of capital to get 6 more unit of labor, which means 15. We got this 15 from 25 minus 10 over 10 minus 4, which is 15 over 6, which is 2.5. Here it means that the firm is willing and able to replace or to give up capital by labor at this rate, which means 2.5. Or we can say it in another way. The firm is willing to give up 15 units of capital against 6 units of labor. And here for this, so here as you can see, the firm is willing to give up 3.75 of capital to get 6 more unit of labor. Here the MRTS is less, so it is decreasing and decreasing again here. So we can see that MRTS is downward, it is decreasing. And here simply we should know that the less capital we have, less we want to sacrifice. Here we have 25, which is a bit large. This number is large, so we could sacrifice here 15, and this is okay. But here we have only 10. It is not logical to sacrifice more than what we sacrificed before to get the same amount of labor here against 6 units of labor. So this is MRTS, and so we can write the formula of MRTS equals simply the change in capital over the change in labor. Okay, so here MRTS simply equals the change in capital. Here the change in capital is 15 over the change in labor, which is 6. We will get 2.5, which is MRTS, the marginal rate of technical substitution. Then we can find this in another way, which is MRTS equals as well the MPL over MPK. So MPL over MPK, and now we will see why it is like this. So simply here, as we know that MPL, marginal product of labor, we saw this in the first video about the shorthand production. It is actually the change in total product over the change in labor, which means the change in labor actually is the change in total product over MPL, and same thing for MPK. MPK is actually the change in TP over the change in K, so change in K is the change in TP over MPK. And now and this implies that here we know that delta K over delta L is actually this over this. Okay, so that means it equals this times this, actually this times this over this times this here. So we can cancel delta TP and delta TP here, we will get this. So as we said, the MRTS, it equals MRTS equals either the change in K over the change in L, or MPL over MPK. So in the next video we'll explore second K concept, which is isocost line, and we will learn how to determine the optimal combination of capital and labor given a budget constraint. And then we will go step further and see how firms can minimize costs for a given level of output, a crucial step in understanding real-world production decision. So that's all for today's video, and I hope this helped clarify the concept. And thank you for watching.